Hello everyone, you're welcome to solve this nice algebra problem, which is 2 to the power m plus 4 to the power m plus 8 to the power m. This is equal to 39. What is the value of m? Solution from here, we have 2 to the power m plus 4 to the power m plus 8 to the power m. This is equal to 39. We can express 4 as 2 to the power 2, and we can express 8 as 2 to the power 3. Substituting this, we'll have 2 to the power m plus 2 to the power 2 raised to the power m plus 2 to the power 3 raised to the power m. This is equal to 39. Now, given the exponent property that a to the power n raised to the power m, this can be expressed as a to the power m raised to the power n. So applying this exponent property, then here we'll have 2 to the power m plus 2 to the power m squared, then plus 2 to the power m raised to the power 3. This is equal to 39. Now from here, we can just say let 2 to the power m be equal to x. Substituting x here, we'll have x plus x to the power 2 plus x to the power 3. This is equal to 39. And we should note here, m is actually a member of real numbers. M is a member of real numbers. So from here, we have x to the power 3 plus x squared. This is equal to 39. From here, let's take 39 on the left-hand side, so that here we have x to the power 3 plus x to the power 2. Subtract 39, this is equal to 0. The next step from here, we have x to the power 3 plus x to the power 2. This is x to the power 2. Subtract 39. We can express 39 as 27 plus 3 plus 9. This is equal to 0. So from here, we have x to the power 3 plus x to the power 2. Subtract 27, which you can express as 3 to the power 3. Then here, subtract 3. Then subtract 9, which you can express as 3 to the power 2. This is equal to 0. So from here, we have x to the power 3 and we have 3 to the power 3. So this is x to the power 3, subtract 3 to the power 3. Then plus x, subtract 3. So this is x minus 3. Then plus x to the power 2, subtract 3 to the power 2. This is equal to 0. So we have the first part here, which is the difference of 2 cubes expressed as a to the power 3 minus b to the power 3. We also have the second part here, which is the difference of 2 perfect squares, which is a squared minus b squared. So let's start with this. We have that a to the power 3 minus b to the power 3. This is the same thing as a minus b. Here we have a squared plus ab plus b squared. So we have x to the power 3, which is x to the power 3, subtract 3 to the power 3. This is the same thing as x minus 3. Here we have x to the power 2 plus 3x plus 3 squared, which is 9. Let's call this equation 1. we have x to power 3 minus 3 to power 3, which is x minus 3, x squared plus 3x plus 9. Let's call this equation 1. Then we have a squared minus b squared. This is the difference of two perfect squares, which you can express as a plus b, a minus b. Now, from here, we have x to power 2, subtract 3 to power 2, which we can express as x plus 3, x minus 3. Let's call this equation 2. So that now we'll have x minus 3, x squared plus 3x plus 9. Then plus, we have here x minus 3, then plus x plus 3. Again, here we have x minus 3. This should be equal to 0. So x minus 3 is common here. So let's factor out x minus 3. So that now we'll have x squared plus 3x plus 9. Then plus x minus 3. This is the same thing as here 1. Then plus x plus 3. X plus 3, close the bracket. This is equal to 0. The next step here, we have x minus 3. This is equal to 0 as the first part here. The second part here, we have x to power 2 plus 3x plus x. This is 4x. Then we have 9 plus 1. This is 10. 10 plus 3. This is equal to 13. And this is equal to 0. Now, from the first part here, we have x1 is equal to 3. x1 is equal to 3. And this is a real solution. This is a real solution. The second part here, we have a quadratic equation, which is of the form ax squared plus bx plus c. This is equal to 0. So this implies that a is equal to 1, b is equal to 4, and c is equal to 13. So let's determine the nature of the root of this quadratic equation. To determine the nature of the root, we assess the discriminant value, which is b squared minus 4 times a times c, and check if this is less than 0 or greater than 0. Now, we have b squared, which is 4 squared minus 4 times a, which is 1, times c, which is 13. So 4 squared here, this is 16 minus, we have 13 times 4, and this is equal to 52. So we have 16 minus 52. We have 16 minus 52, and this is the same thing as minus 36, which is less than 0. So this implies that here we have two complex solutions. We have two complex roots, or rather solutions here. This will give us two complex solutions. So we have two complex roots. Two complex roots. And this one will not give us a real solution. This will not give us a real solution. So we only have a real root, which is x1, which is equal to 3. Now we have that the quadratic part, we have that the nature of the root here, this is negative 36, which is less than 0. This will give us a complex solution, not a real solution. And remember that the condition here, that m is a member of real numbers. It's a member of real numbers. So from here, we have only x1, which is equal to 3. Now, if you recall here, we are saying that let x to be equal to 2 to power m. So let's substitute here. So 2 to power m, this is the same thing as 3. So to solve for the value of m, we introduce logarithm on both sides. So here we'll have log 2 to power m. This is equal to log 3. So log 2 to power m, this is in the form of log a to power n, which you can express as n log a. So this is the power rule property of logarithm. Then that's log 2 to power m. This can be expressed as m log 2. This is equal to log 3. So let's divide both sides by log 2 here, by log 2. So that now the value of m here is equal to log 3 divided by log 2. So m is equal to log 3 divided by log 2, and this is in the form of log a divided by log b, which we can express as log a to base b. Applying this logarithm property, then the value of m will be equal to log 3 to base 2. Now this is the value of m. This is the value of m. So let's verify that this value of m actually satisfies the equation. Now if you recall here, we end at 2 to power m plus 4 to power m plus 8 to power m. This should give us a value of 39. Now let's verify that m, which is log 3 to base 2, actually satisfies the equation. Now if you recall here, we end at 2 to power m plus 4 to power m plus 8 to power m. This is equal to 39. Let's substitute the value of m so that we'll have 2 to power log 3 to base 2 plus 4 to power log 3 to base 2 plus 8 raised to power log 3 to base 2. This should give us a value of 39. So here we say that we can express 4 as 2 to power 2, and we can express 8 as 2 to power 3. So this is the same thing as 2 to power log 3 to base 2 plus 2 to power 2 log 3 to base 2, then plus 2 to power 3 log 3 to base 2. This is equal to 39. This should give us a value of 39. So here we have 2 to power log 3 to base 2 plus 2 to power, now 2 is a power here, so this is 2 to power log 3 squared to base 2, then plus 2 to power, now this 3 is a power here, so we'll have log 3 to power 3 to base 2. This should give us a value of 39. So 2 to power log 3 to base 2 and 2 to power log 3 squared to base 2. The same thing here with 2 to power log 3 cubed to base 2. This is in the form of m to power log a to base m, which essentially will give us a value of a. And therefore, 2 to power log 3 to base 2, this will give us a value of 3. And we have that 2 to power log 3 squared to base 2, this will give us a value of 3 squared. And 2 to power log 3 to power 3 to base 2, this will give us a value of 3 to power 3. So let's substitute these values here. So 2 to power log 3 to base 2, this is the same thing as 3, plus 2 to power log 3 squared to base 2, this is the same thing as 3 squared, and this is equal to 9. So we have 9, plus 2 to power log 3 cubed to base 2, this is 3 cubed, and this is equal to 27. So plus 27, this should give us a value of 39. So 9 plus 3, this is 12, plus 27, this is equal to 39. And this is equal to 39. So the left hand side is equal to the right hand side. And that affirms that the value of m which is log 3 to base 2, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe. Kindly subscribe. So see you in the next video. Bye bye.